All right, so question 7, making sure that Zoom, I'm not muted. All right, we'll try this. Hope this works. Question 7 from the homework from module 6 homework says, determine the frequency that a hydrogen atom emits. Determine the frequency of a photon that a hydrogen atom would emit from the n equals 6 going down to the n equals 3 transition, right? And so for this, we looked at 2 different equations, right? The first one that we talked about was the Rydberg equation that relates those, where it was or the Balmer series equation that uses Rydberg's constant. That was 1 over wavelength equals Rydberg's constant, which is 1.097 e to the 7, and it was 1 over our final quantum level squared minus 1 over our initial quantum level squared. So we can find 1 over wavelength equals Rydberg's constant times our final quantum level, right, is 3. Our initial quantum level was 6. So we have 1 over 3 squared minus 1 over 6 squared. So we get 1 over wavelength equals 1.097 e to the 7, right? 1/9 minus 1/36. And then from there, I'm gonna need my calculator for the rest of it. All right, so let's see. 1 over 9 minus 1/36. Then multiply that by Rydberg's constant, so times 1.097 to the 7th. And so probably one mistake someone might make is they might just stop the calculation there and okay, I've got, this giant number, 914,166, but I want the inverse of that, right? So I can multiply both sides by wavelength. Wavelength cancels out. I get 1 equals this number times wavelength. I want to solve for wavelength, so I'm going to divide by 914,166 by both sides. So I can solve that my wavelength is, so 1 divided by that, my wavelength. I don't know why my calculator is not putting it in scientific notation anymore. Let's see, 1, 2, 3, 4, 5, 6. E to the negative 6 meters. Now that I know my wavelength in meters, how would I find the frequency? What relates wavelength and frequency? What's that? They're inversely proportional, yeah, but the relationship, that the equation that relates them, right? We know speed of light equals frequency times my wavelength. So we know my wavelength now. We also know speed of light, so we can solve for frequency. So divide both sides by wavelength because we're looking for frequency. So frequency equals speed of light over wavelength. Frequency equals 3 e to the 8 meters per second over 1.094 e to the negative 6 meters from my wavelength. So meters cancels out, which is good because I'm looking for my frequency, which should be inverse seconds. So let's see, speed of light, 3 e to the 8 divided by that answer. And I get, 2.74 e to the 14th for my frequency. All right, which is choice B, it looks like, on this for the homework assignment. So we could use the Balmer series. We could also use that equation that we talked about towards the end of class for the Bohr model, where it also involved n final and initial. And that would let us find the energy. And then from energy, sure, we could find frequency as well. So there was no direct route. Either route we would take, we'd have to do two separate calculations. One to find the wavelength or frequency, and then the next one, or sorry, one to find the wavelength for energy, and then the next one to find the frequency. Yeah.
Can you kind of explain the units there? Like, how do you get the inverse?
Yeah, because we're over.
We have seconds on the bottom of the fraction, so that means that the power on it would ultimately be -1 if you were converting it to the numerator, which would be inverse seconds over 1. Okay.
Yep. Or hertz, or however you want to talk. Yeah, they talk about it as hertz here, which are inverse seconds, 1 over seconds. Sorry. So yeah, we would have 1 over seconds for our units. What else do you want to take a look at?
22 and number 13.
Yep.